Good morning to all. Today we are going to discuss the topic that is assembler design option. Here we will discuss the structure, the logic that will be used by different assembler available, and we will discuss one pass assembler, load and go assembler, that is the part of one pass assembler, and then the multi-pass assembler. Okay, so first we will discuss one pass assembler. These one pass assemblers will be used when it is necessary to avoid a second pass over the source program, when we want that our program should not go into the second pass. Second pass, mostly what will be done? Our source program will be done converted into object code. And if we want to avoid that, in one pass we can make symbol tables, we can define their addresses, and later on it will be converted into its object code in one pass only. So no need to go into the second pass. But the main problem in designing the assembler using symbol pass is the forward reference. Like if we are trying to make our source program into the object code in one pass only, there may be situation that some symbols that are already being used but they are not defined in our program. But when we are making that code in object code, at the same time there may be a problem. To refer that operand, that can be data items or a label on instruction. So this can be avoided to some extent. This problem of forward reference can be avoided at some extent only with the data items. Only with the data item we can solve this issue by for eliminating the forward reference to data item by defining all the storage reservation statement at the beginning of the program. Like if in my program some statements are there who are reserving some space in the memory, so all those statements will be defined at the starting of the program. Like we used to define one subroutine at the starting of the program, and later on it when it will be called, compiler will be known, okay, this code is already defined. In the same way, the statement that are actually reserving some memory, those statements will be defined at the starting of the code. So no forward reference issue will occur. But this solution is not good for the labels that we are putting on instruction. So this is not good for forward reference to the labels, cannot be avoided. To provide some provision for handling forward reference by prohibiting forward reference to data items only. Means if we want to avoid this forward reference, we can only do that with data items. So there are two type of one pass assembler. One is load and go. Another is the journal. So load and go is the one type of one pass assembler in which when our source program will be converted to object code, it will be directly ready for execution. Immediate execution will be done for our object code. So load and go produce the object code directly in the memory for immediate execution. Means where our program is on the same place, our object code will be generated at the same time. And another one is the normal, where object code will be generated but that will be used for later execution. So in that case, a reallocation may be there. We need to reallocate memory to bring that into the memory for execution. So we are now going to discuss the load and go assembler in detail. Load and go assembler generate their object code in a memory for immediate execution, that we have already discussed the one line definition, that here the object code will be generated in the memory at the same time, and that object code will be ready for execution, and it will be useful for program development, program testing. But here no object code will be written, that will be stored. There is a no concept that I will create one object program, it will be stored, and it will be bring back into memory. So all these concepts will not be there. It is written that avoid the overhead of writing the object program out in the memory and reading it back. So both one pass and two pass assembler can be designed based on the concept of low and go assembler. Okay, so no object program is written out, no loader is also required, because no need to load this program again, because the program, the object code will be there in the memory, so no need of loader also. However, one pass also avoid the overhead of additional pass over the source program. For load and go assembler, the actual address must be known at assembly time. Means whatever the symbols, data that we are using, their actual address should be known at assembly time. We can use an absolute program, not a relative address, but absolute address can be there. So how this forward reference is handled in load and go assembly? Like when we are reading the program, scanning the program, if some symbol that is being used but not defined, so in load and go assembler, how this situation will be handled? So in load and go assembler, will omit the operand addresses if symbol has not yet been defined. Like one statement is being scanned, next statement is being scanned, and if some symbol and counter that is not yet defined, it will omit its address, it will write that operand, it will write that symbol in symbol table, but it will omit its operand, it will omit its address. So it is written here that insert the symbol into symbol table, omit the address, and mark this symbol undefined. Okay, enter this undefined symbol into symbol table and mention it as a undefined. Add the address of this operand to the list of forward reference associated with the symbol table entry. Means the address that refer to the undefined symbol. Like this symbol is not defined, what will be the value of this symbol is not defined. But what will be the address of this undefined symbol? That will be added in the symbol table next to this symbol by making a linked list. By making a linked list, one address will be referred for this undefined symbol. When the definition of this symbol will be encountered, the proper address for that symbol is inserted into a instruction previously generated list, using the list whatever the address we have filled earlier. That will be changed, or that will be updated with the proper instruction address. So in this way it will work. Now when our program end, when we reach at the end of program, it will be checked, is there any error? It will be checked whether some symbols are there with this star indicating. That means some errors are there in our program, some symbols are still undefined. Okay, that will be searched, or it is search symbol table for symbol named in the end statement and jump to this location to begin the execution. The actual starting address must be specified at the assembly time. From where our program, our code is actually starting, the actual starting address must be specified at the assembly time. So in this is our code. Okay, first I will show, like, from that code, from the previous code, one symbol table is being generated. Okay, one symbol table is being generated. Now, if I will see one RDREC symbol with the star, if I will go back RDREC here, okay, RDREC symbol is here at line number 50. But when you will see earlier, it is not defined anywhere. It is not defined anywhere till line 50. So till 15th line it is undefined. So it will be put in symbol table with undefined. But one address is given to this symbol. If you will see a arrow is given to one node, and in that node one address is stored for this symbol, where later on when this symbol is defined, the value of this symbol will be stored at this address. If you will see here, from 2010 address is being started. If we will do 2 bytes, okay, then at 2013 this symbol will be stored, but till now it is left blank. Later on, again, if we will see WRREC symbol, okay, WRRC, see here, this is again one symbol that is not defined, okay, that is not defined, and it is already at line number 35, and address is 201E, where it is being used but it is not defined. So here after 201E, the next address will be assigned to this symbol. Okay, it is left blank but its address is defined. Later on, and fill, if I will see and fill, here the unfill is also being used here, but it is defined till defined here. Okay, it is being used at 201B, but it will be used defined later on. So we will give its empty, undefined, but its address will be the next address 201C. So in this way, symbol table will be generated. Later on, if we will see, it is that after scanning line 40, means till the 40th line, if we will see this 40th line, okay, till 40th line, WRCC is also used and fill is also used, RDRF is also used, but these all three symbols are not defined. So that is why till 40th line they are undefined, but one address is assigned to them. Okay. Later on, after scanning line 160, they are saying after scanning line 160, we will see the code again, like till 160 here. Okay. In that, RDREC is defined and fill is defined, but till 160 WRREC is still not defined. So if I will move back, see RDRREC is at address what? It is at define at address 203D. So that will be filled here. Okay, till now we will define the address where it is being used. Okay, later on its actual address will be filled here. Again, WRREC is not defined, but where it is being used. One we have already done in previous program, that it is being used in 201F, and later it will be used in 203 2031. See here, WRREC is being used by 2030 statement at address 2030. So that is why after 2030 next location will be 2031, where it will be temporary or it will be referred. Now, and fill is given the address where it encountered at 2024. Okay, so 2024 is filled there. Later on, the one more symbol is there, exit. Okay, after scanning the line 160, one symbol is still there, that is not defined. So we will see in our program exit is being used here. Okay, that is at location 204F. It is being used here in the location 204F, but it is defined in the location 205B. So here if you see 2050 is for forward reference, and later on when it will be defined after, means after scanning 160. Now after, when we start scanning the next line, it will be filled with 205. In that way our single program will be filled. Okay, so now this is the algorithm. This is the algorithm for one pass assembler. This is the algorithm how it will start reading the one statement, how the addresses will be given at the starting. If that symbol is not there, not defined, we will give the next address where it is being used. We will give the next location at the starting. Later on when it will be defined, at which location it will be defined, that will be put. So this is the algorithm, and this is the object code. And in one pass, as we have discussed, and in load and go assembler we have discussed the main thing, that object code will be generated after scanning each code. After scanning the statement, object code will be generated simultaneously. It will be residing in the same memory where our code is residing. It will be residing in the same memory. So we need not a loader to load this code. We need not any loader to load this code. Now, so we have discussed as a one pass. In one pass load and go assembler is there, that we have discussed. Now we are going to discuss the multipass, and before that I am going to stop here. In next session we will discuss the multipass assembler. So thank you for